All right, hi everyone. So now that we have our Spark cluster set up with one master here, no working nodes configured currently, but we will be adding on later. Let's have some fun with it and play around with it and see how an application is sent onto Spark and how Spark distributes that work to different worker nodes. It's really interesting. I mean, I find it really interesting, and I hope you find it too. Let me just begin by opening an anaconda prompt. So I will be opening a Python notebook, and that Python code I will be running on a Spark cluster. And how do I do that? Well, we will see. So let me just go to the directory where I have the project. And I'm going to open a Jupyter notebook here, which is nothing but a Python running environment on the internet. You can interact with it, it's interactive, and it's on the internet, so it's pretty fun. So this is the notebook that we will be running, and let me just give you a quick high-level introduction to what this code will do. So as it says decision tree classifier with Spark predicting diabetes. So it will basically be using an open source data set, which is a CSV file right here. So it has all these labels or features, as you can see, and an outcome label. So all of these features, pregnancies, glucose, blood pressure, they basically have certain value. And depending on these value, we have an outcome of a 1 or a 0. That means either a person is diabetic or they are not. So depending on these values, what we're trying to do is make a decision tree, and that decision tree will help us classify, again, using those values, whether a person has diabetes or not. And we will be using this as our, well, it's not a really long data set, but we'll still be dividing this between our train and test, because the purpose here is not to use this as an actual model, but just to sort of see how it works in Spark and how it's going to look like. Right, and since I'm running this on a Python environment, I needed to import pyspak, which will help me push this and connect to a Spark cluster and a Spark master. So the next cell is just dividing this 2 CSV data into training and testing. So what I'm going to do is use 80% of the values here, 80% of all those rows is going to go into training, and the rest, 20%, will be pulled into testing. So now when I have my training data divided like this, a single row in my training data, this is what a single row will look like. But this is not the input that my model or my decision tree will be accepting. What it needs is a labeled point. And what a labeled point is basically, let me show you what it actually does. So I am mapping each of this single list, and I'm mapping it to a labeled point as we have imported it up top here. So I'm going to collect it, and this will print results, and which will allow you to see what it is going to do. Okay, so let me also comment this out. Okay, so what a label point does is it extracted the feature that we are predicting, and this 1.0, 0.0, this is basically the this particular outcome value right here. So this is what it will use to train, and then this is the value which will help us understand what the outcome was. And this whole set of lists, these are basically the features. So a labeled point consists the outcome and all of these features which will predict or help predict the output. And this is the sort of structure that our decision tree will be accepting. So uncommenting this line right here because we need our we also need our test data, and here is what I am also going to show what my test points are going to look like. Oops, not points, labels. Okay, so my test labels are just the labels, the rest 20% of the labels 1.0, that means a person was diabetic 1.0. So this is basically what will help me validate my model. So this is my model now. Model is equal to decision tree dot train classifier. So I'm using a decision tree and I'm basically using it on this training data. The one that we showed earlier, which were labeled points. So that is what I'll be running this training data on. I have two classes, two outcomes, a 0.0 and a 1.0. I have 0 categorical features. I'm using Gini impurity, maximum depth 6, and maximum bins 40. Alright. Okay, so now that we have our model, which is trained on the training data, which as we talked about earlier was nothing but a labeled point, which consisted of the outcome, this outcome right here, and a list of all of these features, I will go into predicting. And this is basically, I'm putting it into a variable called test results, and this is going to be printing the decision tree, or what this decision tree is going to look like. You can go and map this and try this by yourself, putting it into a notebook or just some paper, but it is pretty interesting to see how this is going to look like. Okay, so I think I didn't run this cell earlier. Okay. Alright, so as you can see, this is the decision tree, and I think it is really interesting. It says the decision tree model, depth 6 with 69 different nodes. If feature 1, so this was our top feature in deciding. Let's go back and see what feature 1 was. So it's okay, so it's glucose level, so we can say that that's the top sort of predictor. Yeah, so I think you can further go through it while you're running and see and understand the importance of different features in predicting the outcome. Alright, so now what I'm going to do is I'm going to zip together the results from this particular, the test results, which I got out of the model, and the labels that we already have. So these labels right here, and I will try and see how close my predictions are to the actual values. Let's just run this. Well, I can uncomment this and also just sort of see what this is going to look like. So the first is the test label. So these are the actual values, and this is what my model predicted. So looking across it, well, it doesn't look like it's performing really well, but for a decision tree and for the limited set of data that we have, it's fine. It's not the worst. It obviously can be way better, but again, the purpose here is just to see how this is going to look like in Spark, and not to actually increase the accuracy. You can go ahead and try that, and I think it's really, really interesting to see. Anyway, so now I'm going to calculate the mean squared error, and what I'm going to do is just take my labels and take my predictions and calculate the mean squared error, which is nothing but the difference between the predicted value and the actual value, and you take the square, then you take the average of that. Well, I cannot really explain MSE without using math, but I'm going to try my best to just sort of get an intuitive understanding of it. So we have a value 0.246. So as you might understand, mean squared error, this is something that we are trying to reduce and have a value closer to 0. Not the best, but again, not the worst. So I have this, this data set right here, which is just what I'm like using to predict. So there are these people with this these features, and I'm basically be using it to predict whether that person will have diabetes or not. And just going to collect that data, and this is where I'm making the prediction. So this was basically me optimizing the data to be fed into my model as to be predicted. So that was just splitting it by commas and making sure that it is converted into a list so my decision tree can ingest it and give me a prediction. And this is where I'll be making the actual predictions. So as you can see, well, it did predict that none of these people except the last one will be diabetic. So, I mean, good for them, you know. Alright, so let's go and configure some worker nodes, put on a cluster together, and put this code into job. And one important thing that I'd like to point out here is this Spark decision tree.py file, which is essentially the same file as my Jupyter notebook right here. It's just the only difference really is that this is a Python file instead of the IPython notebook, right? So this makes it easier for me to send any jobs or push any model from Python to Spark. I basically just use this to demonstrate how this model is going to work, but for actual purposes, I will be using this Python Spark decision tree.py file, and I have set my master to wherever my master will be running. So I had earlier closed my master, but let me just go in and start this real quick. So this is just going to be Spark class or dot Apache dot Spark, and I'm going to be deploying the master first, and then whatever URL that I get for wherever this is going to be running, I'm going to use that into my cluster for configuring my worker nodes. So master says that it has been elected a leader. I just like really love hearing that from my master. So as you can see, there are no workers, no running applications, or no completed applications, of course, connected to it right now. So I think this is a good time to go ahead and spin up some worker nodes. Similar to how we started our worker, or our master, or Apache Spark. And remember to copy this address right here. This is where our master is, and our workers need to know where this is running. So I'm just going to put up some workers to work. And let's see how it sets up, and if our master is able to access all the workers connected to it. Meanwhile, I'm also going to go in and set another Spark. I can copy that command, but I just want to get into the habit of writing this. It's not a super complicated command. You can also run it via the command files and the shell files that you have, but I just find this one more intuitive and more easier, I guess. Okay. Successfully started. Let's refresh this and see. Do we have, okay, we already have one worker set up. You should also have a second. Great, we have 2 workers set up and 1 master. Now I think it's time to have some fun and see what kind of jobs and how to send our job onto this Spark cluster that we set up. So going into this Anaconda prompt and at the D drive, I'm just going to change or move into the directory wherever I have my project. So this folder right here, which is running on Python D, Python, okay, online, Python projects, Spark, ML. You know, sometimes thick fingers with computers. Alright, to submit any jobs to the Spark context, which in take will take in all of the processing it needs to do, and all of the jobs that are passed into it, pass it on to the master node, and the master node in turn will decide how to distribute it across the cluster, or what sort of operation is necessary to distribute the data and the processing operations. So Spark submit, I'm just going to submit this Python file to my cluster. So I really don't have to do anything else to configure this whole running of my Python notebook, except making sure that my master and my cluster with 2 worker nodes is set up. So when I do Spark submit, Spark decision tree.py, and I hit enter, this is basically going to go directly to my Spark master. So if I were to, so as you can see, as I hit enter, it receives a running application. So it's using 16 cores, 8 cores from each of these nodes. So 8 from this and 8 from this makes it a total of 16. It has both of these workers on there. The state is finished, so the executor summary I cannot really see because the job was pretty fast and it was done by the time I got here. It took 35 seconds and it was finished in 35 seconds. If I were to go in and look at my Anaconda prompt, I would see that it would have printed me these predictions. These are the predictions for my prediction that I'm sending in. So this was basically this custom inputs that I was using for my model. You know, not the test models, but the prediction model. And there must also be a model. Okay, here it is. So this is my model. And as you guys remember, I have set up the log to output all of these infos. So we can change that from the configuration files to only output to the log whenever we have an error, but this is how it is set. We can change it. I'm not going to change it right now because I feel like this gives me more information, and I can see where my current, where I am at the current processing. So going back to this is Spark Master, it took 35 seconds when I had 2 different clusters or 2 different workers in my cluster. Let's see how long would this job take if I had 3 worker nodes in this cluster. You know, it's not always that you will see any change. A lot of the times, for you to be able to decisively tell that something is working, like a cluster for you is working, is when you have a bigger amount of operations and a large amount of data, which I don't. So, but just for some fun, you know, let's just see. Worker. Okay, let me just copy this address right here. Okay, so this is going to be my 3rd worker. I already have 2 set up. Let's see. Pretty exciting. Okay, it seems like, okay, this shouldn't be submit, this should be class. Now, sometimes make sure that you're running the right commands. Log4j. Okay, this seems to be working. Okay, awesome. This has successfully set up. So this 3rd cluster has popped up again using 8 cores, 14.9 gigabytes, which quite honestly is a lot of space. Let's just go in and execute that command again. So I'm again going to be submitting that job to this whole cluster and see how my master is going to split that task up, and will that actually affect how efficient this, will we be able to reduce this duration, will we be able to make it more efficient. Let's see, let's refresh this. I have this running application, so good that I caught it here right now. Okay, well, it seems to me, okay, so as you can see that it is performing these operations. Let's refresh it. Well, it does seem like it does take more time than the previous one was taking. So it is running the job, it has collected whatever RDD that I told it to collect. So it has succeeded the first job, it succeeded the second job. Okay, I'm gonna go back. I'm going to see how long has it. Okay, it turns out that 3 clusters after all is not a really good system for our really small classification or decision tree classification model for Python. It took almost double the time. So intuitively it might seem that 3 clusters is going to take maybe around the same time or less time than 2 did, but it's the opposite case here, because I feel like what's happening is since we do not have a lot of processing, sending data to 3 clusters and bringing data back from those 3 worker nodes, I'm sorry, not clusters, it's taking more time than doing that. So yes, we did figure out that in this situation, in our example, 3 nodes is too many cooks and it has spoiled our tomato soup. Not the ideal way to go. What happens if I shut down these 2 worker nodes and I only have 1? Do we think that that is going to increase our performance, knowing that we do not have a lot of data, we do not have a lot of processing to do? Why complicate stuff? Let's just, I'm going to shut down 2 of these worker nodes, and I'm just going to make sure you're shutting the worker and not the master. Well, doesn't really matter, you can set it up again, but you know, it's going to be a little inconvenient. Alright, so all of, out of these 3, I killed 2, too bad. One of this is an alive worker node. Alright. So let's go back and submit our notebook or our code to the cluster. So let's just, okay, so this is running 2 second, 8 cores, just a single node. Running executors, one running executor, Spark decision tree. Gonna go back to master. Alright. So if I were to click on application detail, 0 of 2 jobs completed. 2 jobs are running. None have been completed right now. But we do have time. Let's see if we are able to. Okay, well it seems like all of the jobs have been completed. Yeah. Let's go back to localhost 8080 and go back to master. Okay, I'm still at this. Okay. Well, a single node took 52 seconds, which is better than 56 is, so this was when we had 3 nodes, but it is worse than when we had 2 nodes, right? So, moral of the story, maybe 2 is better than 1 is, but 3 is definitely not better than 1 or 2 is. But this is only suitable, or was only for testing purposes when I'm trying to see, or when my data is not that super complicated and when there's not a lot of processing to do. Let's just, for fun, just close this worker node too and see what happens when I try and submit a job to a cluster with 0 working nodes. Will this job execute? Good question. Let's see what happens. Seems like it is setting up the permissions, it is going to be doing all of this scheduling, connecting with the Spark context, making the DAG. It is running, but it is hardly supposed to run. It's still waiting. It's not running. It's still waiting for a worker to be attached to it, to assign this job to somebody. So this will keep on waiting until I add a worker to it. So again, that's not needed here, as we already saw how it would work when we have 2 and 3 and a single worker node attached to this cluster. So let me just end this. It's going to take up a lot of memory of my system. Control C, and yes. All right. Okay, I will be wrapping things up now after just running through what we went and discussed a bit earlier. So this was our Python code that we were running, which was using a decision tree model and a diabetes.csv data set to determine if a person is diabetic or not. And we were using mllib, which is a library from PySpark, and trying to run that job on a Spark cluster with a 1 node, 2 node, 3 node, and no nodes. And what we figured, looking at this diagram again, or looking at this table, not diagram, when we had 16 cores, so we had a worker 8 core each, so when we had 2 workers, it was the most efficient processing of data, of processing and completion of that job. It was the worst when we had 3, and it was intermediate when we had a single worker node. So again, this is a trade-off between time and understanding your system capacity and capabilities. What is best for you? What sort of system that you have? What sort of data and operations needs to be performed? Because not always is more optimal. Not always is more number of nodes the better option. And for 9 seconds was when I aborted the job. There were no cores attached to it. My application was still waiting to be executed, so I just canceled it, and I canceled it around 50 seconds. It kind of fits into this timeline. But yeah, that was an overview of how can we have jobs that are sent to master, and how does master basically split that to the workers. So even though our workers had a lot of memory and had a lot of cores, and master did split it up into 3 different worker nodes. I hope that was intuitive, and that helped you sort of understand how this whole ecosystem works and what would happen if you have a large amount of data and lots of processing to do. It essentially is going to work similarly. All right, thank you, and I hope you continue your journey with Spark and with just seeing how distributed systems in generally work, because they're so interesting and complicated, but really fun. All right, thank you.